want to talk about polarization. Hopefully you noticed that I posted another video about polarization, and hopefully you've already seen that, because in that video they do a good job of explaining how we know light is a transverse wave and showing how transverse waves can become polarized, and in general just how polarizing filters work. So if you haven't watched that, I encourage you to watch that first before watching the rest of this video. That video is short, it's not even 2 minutes long. Again, they just do a good job of explaining the basics, but they don't explain everything. And there's a couple things that they left out that I really wanted to discuss and show you. So what I've got here is a polarizing filter, or some people call it a Polaroid. Either term is fine. This one, its axis is vertical. And so that means that when the light passes through it, it's vertically polarized. And as they showed in that other video, let me just show you here, I've got a second filter, and if I put them over, when their axes are aligned, you can see right through. It's no problem. But if I rotate one of them 90 degrees, now their axes are perpendicular, and you can't see through. So that's the idea here. If they get perpendicular, then no light can get through. Now, I should mention one filter by itself. If you just have unpolarized light coming in, one filter is going to block about 50%. You know, if it's perfectly randomized, it's going to be 50% that it blocks, only 50% gets through. Now, one thing they really didn't address in the video that I wanted to talk about here is glare. So it turns out that when light strikes a surface, it tends to become polarized in the plane of that surface. So if it strikes a horizontal surface, that means the light is going to become horizontally polarized, mostly. If it strikes a vertical surface, it's going to be vertically polarized. So I want to demonstrate that. So what I've got is my phone here. Let me get this set up here. So you can see the reflection of me, my face anyway, a little bit there. And if I just take my filter here, get this straight, okay, and I just bring it down, you can see the reflection of me disappears. And just to show you, there it goes, it reappears, and then it disappears. And that's because those light rays are becoming polarized in the plane of the front screen of my phone. And so as such, when this comes up, you know, they're 90 degrees to this, and so they're blocked. They don't get through. This is why polarized sunglasses are so practical. If you're wearing them and you're driving, it's going to block a lot of the glare. So any of the light that bounces off the road a certain way, it's going to block that glare. And the same for if you go fishing. It's going to block the glare that comes off of the surface of the water. It's going to allow you to see into the water. That's assuming the water is calm. If it's really choppy, that won't be the case. But if you've got pretty much a calm surface, it's going to allow you to, it's going to block that glare and allow you to see into the water. And you can see what's in there. You can see the fish and whatnot. One thing to mention, this is a way to test polarized sunglasses. I know you'll find this surprising, but sometimes glasses, they claim they're polarized, but they actually aren't. But it's easier for you to test them. You can just take them out and you can just look to see, you know, by rotating them, do they block the glare or allow it? Or you could take two and cross them to see if they block all the light. So these are ways to test to see if the sunglasses are indeed actually polarized.